The next entry in the toolbar is the Bevel tool. The main, but not only purpose of this tool is to add a roundness to otherwise sharp edges. For example, if we zoom in on a cube, we can see the razor-like edge between the faces. If we select this edge and then choose the Bevel tool, we'll see the familiar yellow head pin. And if we drag on the pin, the single edge is transformed into a face, whose width we can control by further dragging. Although this seems a simple enough operation, when we look at the last op panel it creates, we can see that there are many parameters. Affect is the first parameter, allowing us to choose between beveling the selected edges or the selected vertices. Width type is a drop-down list allowing us to select exactly how the width of the new face or faces is measured. We can see in these diagrams what measurement each option represents. Most of the time, you are not going to see a difference between offset and absolute. But in this image, we can see how they differ when an edge passes through the area to be beveled. Width is the actual width of the face. The label associated with this field changes to width percentage if width type is set to percentage. Segments sets how many faces are created in the bevel area. As we increase these, we create a more obvious curve. Shape adjusts the shape of the curve, although, in practice, we need to set segments to a value around 5 or more to achieve sufficient definition in the curve. Material index is important if we are planning to assign one or more materials to the mesh. The default value of -1 sets the material to be the same as surrounding faces. This is somewhat unpredictable if those faces have been assigned different materials. Other values correlate to the index number of the materials list for the mesh that's being edited. To demonstrate, we'll set up a different material on each of the faces of our cube. When we create the bevel, the new face is assigned the material of one of the adjacent faces, but the exact material assigned by the -1 value in the material index field is hard to predict. Since the cube makes use of 6 different materials, we can change this field value to any value between 0 and 5. Harden normals adjusts the normals where the new bevel faces meet the existing faces to subtly adjust the shading. In the image seen here, the cube on the left has standard normals, while the one on the right has the harden normals option activated. The difference is usually very subtle and may be difficult to see on the video. Clamp overlap ensures that the bevel we are creating does not overlap any existing edges. In the example here, the cube has a loop of edges just below the top face. If we bevel the edges around that top face, we can adjust the width so that its leading edge passes the existing edges, giving a muddled mesh geometry. But we can avoid this from happening by activating Clamp Overlap. Now, Blender will not allow the width to extend past those existing edges. Loop Slide, which is selected by default, doesn't affect simple bevels. But to show the effect it creates, we'll start with a cube that has a set of edges that cut through the faces at an odd angle. If we bevel part of the cube, the Loop Slide option adjusts how the angled edge is handled when it passes through the new bevel faces. We'll leave Mark Seams and Sharp for a later video. The next 3 parameters again need something out of the ordinary to show the effects they create. So, we'll start with the modified cube shown here and select these 3 edges to be beveled. We'll set segments to 6 to allow enough detail to show off the various options. Miter Outer offers 3 options: Sharp, the default, Patch, and Arc. Each option adjusts the faces created at the intersection between the vertical and horizontal bevels. Miter Inner affects this part of the bevel. When set to Arc, a new field labeled Spread is added. The value here affects the size of the arc and therefore the surrounding faces. The various combination of miter outer and miter inner values each create their own unique look. Intersection type, when switched to cutoff, leaves the area where horizontal and vertical bevels meet as a much simpler structure which is not affected by miter outer or miter inner values. Face strength is yet another topic for a later video. While the shape parameter gave us some control over the shape of a bevel, profile type will give us much greater control, and that is the subject of our next video. When we are using the bevel tool, a set of parameters appear in the top left of the 3D viewport, where we can set the offset type, number of segments, and type, where we select to bevel edges or vertices, and finally the shape value for the bevel. As with the other tools, Bevel has keyboard shortcuts. This time it's Ctrl-B to bevel edges and Shift-Ctrl-B to bevel vertices. Moving the mouse sets the width of the bevel, while rolling the mouse wheel will set the number of segments. Left-click to complete the operation or right-click to cancel it. In the top left of the 3D viewport, basic details of the current bevel operation are displayed. Although the bevel tool is most often used to soften sharp corners, it can also be used to add more edges on a flat face as we see here.